You were having a good day. And then you remember you're studying computer science and there is no such thing as a good day. Your day was fine, not good, it was fine, but then you had to insertion sort a linked list. How would you go about doing it? So let's say we are given a linked list here. So we have a linked list. Head points to the first node as it always does. So head points to the value 4. 4 points to the value 3. 3 points to the value 2. 2 points to the value 1. 1 points to the value 6. 6 points to the value 5. And when you see this kind of arrow, it means null pointer, indicating end of linked list. How would you go about using insertion sort to solve this? Let's go ahead and call this solution. The solution is actually quite straightforward. So we read in nodes. We read in nodes from the unsorted linked list. We then determine the position 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 of the node in the sorted linked list. Now, the linked list pointed to by head, so this one up here, this is our unsorted linked list. And you may be asking the question, where is the sorted linked list? This is how we go about doing it. Let me just scroll down here. The first step is we create some new linked list. Let's call it sorted linked list. We'll just call it sorted for now. And it will point to the first node from the unsorted linked list. If we go up, we notice that the first node is 4. So it'll point to 4. After which, we start reading in nodes from the unsorted linked list. And then one of 3 possibilities can occur. So let me go and write this. Once we start reading nodes, one of 3 possibilities can occur. What are those 3 possibilities? Let me just go ahead and see if I didn't write it here. I think I did. Okay, so. Okay, yeah, here we go. We read in a number. The number is either the largest and will therefore be appended to the end of the linked list, or it will appear between nodes A and nodes A plus 1. A is an index. This is our, let's call it, let me actually go to the bottom. That should not have happened. So, one of 3 possibilities can occur. So what are those 3 possibilities? 1. The node red is smaller than the current smallest node. So all this means is, let's say we have some linked list, let's call it sorted, and it points to some value, let's call it 4. We then read 3. We notice that 3 is less than 4, so all we have to do is this. We will have 3 point to 4, thereby creating a link, and we have the head point to 3. So now what this ends up being equal to is sorted points to 3 points to 4. There we go. The second possibility, we read a value. We read a value larger than the value, than the starting value of our linked list. So we currently have sorted is equal to 4. I mean, it's pointing to 4, which points to 3. And let's say we read in the value of, with my mistake. So sorted points to 3, which points to 4. And let's say we read in the value 5. So what happens here? In this case, what we want to happen is sorted should now point to 3. 3 points to 4. And we have to somehow have 4 now point to the new larger node 5. We'll get that in the code. The third case is, let's go. So the case 3. We read a value. We read a value. The value is larger than the first node. But it is not the largest. But it is not the largest. So what this means is, let's say we have a new linked list, let's say sorted. It points to 3, which points to 4, and this is sorted. And then we read in the value 6. Where does 6 go? Well, 3 is less than 4 and 4 is less than 6, therefore 6 is the largest. So sorted should point to 3, 3 should point to 4, and 4 should point to 6. Great. This is case 2. But what if now we read in another node 5? What should happen now? Well, in this final case, let me change the color. We should have sorted pointing to the node 3. The node 3 points to the node 4. The node 4 should now somehow have to point to the node 5. And node 5 now points to node 6. Node 6 will just refer to null pointer. And this is our 3 cases. We'll get to the code in a minute. Maybe a few minutes. I think I have it better explained above. Okay, here we go. Notice this. We initially have some linked list. Let me zoom in. Okay. We initially have some linked list, sorted list, which points to 4. We read in 3. This is case 1. 3 is currently smaller than the smallest node. This is the easiest case. So what we have to have now is sorted list point to 3, 3 points to 4. We read in 2. Just as in the case above, it is the smallest value. So sorted list will point to 2, 2 will point to 3, 3 will point to 4, 4 points to null pointer. We read in 1. It's just as in case 2 and case 3, it's the smallest. Therefore, sorted list will point to 1, 1 will point to 2, 2 will point to 3, 3 will point to 4. And there's our next case. We read it, so from here, we read a number. The number is either the largest and will therefore be appended to the end of the linked list, or it is large but not the largest. It will appear between nodes A and nodes A plus 1, where A is an index. Here's an example. We read in 5. Our sorted list is now 1, 2, 3, 4, 5. How do we do this? Well, we have to traverse the sorted list and determine position. If we set current to point to sorted list and current next to point to the next node, we may be able to get this done. I'll explain it in the next video.